My name is Gueorgui,
And my name is Jeremy Reisig.
and this is our heat exchanger design for the HPC at MSU. The design objective was to design a shell and tube heat exchanger for the MSU High Performance Computer Center to cool the computers. Environmental aspects as well as the cleaning factor are to be considered in the optimal heat exchange design, and the length of the total design should not exceed 25 feet in length. Pressure drop should be minimized, and the heat exchanger should remain relatively cheap to satisfy all other design constraints. The MSU computers generate 1 megawatt of thermal energy continuously. Water is to be used for cooling from the reservoir at a steady flow rate of 1 million gallons per day, and the temperature of the water leaving the reservoir is set at 57 degrees Fahrenheit. Heat enters the system at 120 degrees Fahrenheit, and the inner diameter should be 14 inches. For our initial trial, water was chosen as the hot fluid of the system. The heat exchanger failed to dissipate all the heat to the cold stream due to the mass flow rate of the system not being enough. The combination of high heat and not enough cooling is reflective of an inequality in an energy balance of the system, and the thermal energy is recalculated to find the allowable system parameters.
After several iterations of testing, an optimal design for the heat exchanger system is found. The geometry used for the system used a Type E heat exchanger layout for a single pass with a 45 rotated square tube pattern to change the inside baffles for the system. Carbon steel is the material chosen to be used for low maintenance costs of construction, with a tube length decreased to 20 feet to fit within the specified parameters. The overall performance of the system resulted with a lower cost of around $20,000, with low pressure drops fitting within the allowable limits for both the tube and shell side pressures. Additionally, there are no vibration or Rho v2 problems, making the system stable. Based on our optimal design findings, suppliers are chosen for the heat exchanger system for construction based on the supplier's ability to manufacture and make the heat exchanger for the materials. The Kerr Pump and Supply, located in Oak Park, Michigan, is chosen as a primary supplier for heat exchangers and pumps due to the manufacturer's ability to machine several material types, such as carbon steel. Additionally, Armstrong International Incorporated, located in Three Rivers, Michigan, is chosen as a secondary supplier for tube and shell heat exchangers design, specializing in alloys such as carbon steel designs.